So the next part is to tokenize the input text, which is over here. I might actually get rid of this because we just want to create a bit more space. I'll hit a plus as well, make it a bit bigger, the font. Get rid of this. So we want to tokenize the input text, and in order to do that we need to do two things, which is create a mapping between the characters and the strings. And so I've created this variable here, and I've kind of like, again, like the tutorials are kind of like assume that we know all of this, but I'm actually going to dig into it and like show what each part of this means. So it's a much deeper dive. But string to it, str to int is basically we're going to have a method of converting strings to integers. So we're going to store that into a variable, and that will be a dictionary here. So we've got a dictionary, and then we're going to do integers to strings. So int something like to string str, so going the other way round. And again, it will be a dictionary of some kind. Now this is a dictionary comprehension. What is enumerate chars? And if I just go back to the Control J to pull it up and get the characters, you know, the enumerate method here just basically everything in a list. So here is our list, and everything is, here's all our values. So we've got, like, it looks like a space here, and actually looks like two spaces here are actually counted in part number one. So this looks like one space, and this is potentially two spaces here. But all of our characters are, all of our values are here. So, and our values are our characters, whatever characters there are. But also in the list of characters is the index number. So index number 0 is this, like, it looks like possibly a single space, and this one's a double space. In index number 1, index number 2's got an exclamation mark, and scrolling down, I don't know, like index number 31 is a capital S. And you know, if you wanted a small s, it would be index number 57. So the enumerate function just kind of like identifies the index with the actual value. I'll keep that up in the background. So the list comprehension is literally doing character colon I. So it's creating this dictionary character colon I for I comma character, because the enumeration is index comma value in the enumerated characters. And we could kind of just run this. The second one will be blank. So let's just run that piece of code. And we're not going to look at into string because that's empty at the moment, but we did populate the other one. So we can kind of like see it there, string to int. I wonder if we open it, if we get a dictionary look of it. No, it looks kind of like very similar. But a print of it might be better in that case. So let's just do a print here just to show. But print str to int. So string to int. This is the one that we've created, the top line over here. This is the one that we've created, and we can see what it looks like, which is basically just a dictionary. So the first one of this is actually it wasn't a single space. This one, index number 1 is a space. Index number 0 is actually the new line, the carriage return. So that's what that one actually contains. So that was quite a nice little debunk of it. So we've got carriage return here, colon 1, colon 0. So that's getting our strings converted to integers. So a space is at number 1, an exclamation mark has got the value 2. So now we've got this nice looking dictionary effectively that contains all of our numbers, and it goes all the way up to well, it's going to be 64, but I think that means it's 65 because remember we start at index number 0. So I think we can now do the enumeration, getting ourselves from integers to strings, going the other way. And the reason why we're doing this, or at least one reason why we're doing it in terms of like Python or whatever, is if we take our stuff out of the list and put it into a dictionary, the lookup's quicker. So I believe that that's the process for that. So we're going to do the backward version of it. I could actually just copy all of this and paste it into here just like that, and switch these around. So this time we're going to have I and characters. So ICH, and then for ICH in enumerate. So we're going the other way around. So we can actually print that one out too now. So let's, in fact, we can, let's just do this, strut to int. That's one way, that's going forwards, should we say, and we've got now the other way, which is copy that, paste it on the next line, and we've now got int to strings the other way round, which is int to strut over there, and we can run that, and we've just flipped the key value pairs the other way round. So we've got both. We can now go from integers to strings, and we can go from strings to integers. So the next thing that we need to do is to do some encoding, and in the at least in one of the videos that I've seen, it uses a lambda function, but I'm not a huge fan of lambda functions, so we'll just do an encode function, or our, like, explicitly. So and one thing why is the lambda functions, I mean, they're great, but they're not descriptive, and then when you go back you can't tell what your function actually was, or like anyway you needed to put some sort of comment on the lambda function, so it's better to have it in a doc string, and it's a bit cleaner for when you go back to remind yourself. So encode, this is our function, is to encode something, and what we're going to do is to take a string and return a list of integers. We can take a string and return a list of integers. That's what this function is going to do. So we could generate this like result, effectively result, and we could use list comprehension in Python, and we will take our, what we're going to do is now look up our dictionary. So for each for each character in our string, so we're going to do a lookup, and we're going to get str to int. So we're going to get the integer value of the string for C in S. So we're going to take in this value, we're going to take in a string. This function effectively is going to take in a string. We can even label it string. This is the nice thing about it. We can type hints, although we know it's going to be a string. So when we hover over our function now, it just looks like a nice complete Python function. The user knows to, how about spell encode right? How let's spell encode right? E-N-C. So encode. The user can see that's a function, encode. We're taking S, this variable S, which is a string, and we're actually going to return back the result. So that will be result, and we can see everything nicely formatted. So we can take in a string, and then we're going to return back a list of integers. And so string to int here is basically it's our dictionary, which is our first dictionary. So we're just literally taking in any character. So if we had the character, it's hard to scroll. Oh yeah, I can scroll across a list. If we take, I don't know, the character E, capital E, then we're going to convert that into a 17. And if we've got the character K over here, small k, we're going to convert it into the number 49. And hopefully that this function will work. So if we do something like, we can try it out now, encode, and these encodings are just literally taken from the original data set, from everything that we've scraped out of the original Shakespeare data set. So we've organized them in a way, and we've like sorted them, and we've got like 65 characters, and we've put them into these dictionaries, and our dictionaries go all the way up to 65, or they go up to number 64 because it goes from 0 to 65. That was the length of it. So we're just, for any character that we get, that's what we're going to get back. So let's just do an encode just to try that out. So encode, and then we're just sort of like encode hello world, hello world. We'll just encode hello world and see what we get back. We can select run that now. And there we go, we get back this string here, hello world. In fact, we'll put like test encode or print. Yeah, we'll print out encode, I have to use these double quotations, but hello world, and that will kind of like give us this thing back, right? It'll give us the encoding of hello world. So hello world basically now gives us back this, and we're going to have to create a decode function next. So I'm just wondering if the decode will be nearly identical, but we'll definitely do a def of the function, and instead of encode we are going to have a decode over here, and I think we're going to take in integers over there. So in fact it looks like I think we're going to take in the list, because what we've encoded, we want to get this back, so we've got to get this list back. So it's going to be like we'll call it L, and that will be of type list basically, and we want to get back, I'm presuming that we're going to get back a string is what's going to come back. So our result will be some kind of string. We don't know what it's going to be, but and we're going to return result. So we'll return result like that. So like our function is nicely formatted in a way, and here we will just change the doc string and put this in here, and we are going to take a list of integers. So cut that out there and return a string back. So we're able to encode one way, and we are, hopefully if we get this right, we'll be able to encode the other way, going backwards. So we can encode and then we can decode. So what I think we can do is I'll do this result just again, because I'm bound to screw this up, because it's all in like live or real-time result is equal to, and we're going to use this dot join method again. So dot join, and then we are going to let's just do that. We're going to join. We're going to join the over there the integers to string, so int to string this time. So we're going the other way round. So before we went from string to int, now we're going for int to string, and then I for I in L. So if this does work, we could comment this one out. If this does work, we are going to do the reverse lookup on this dictionary. And so if we've got these like number 46 here, for example, we can sort of like scroll across and we see number 46 is over there. Number 46 is this little h for the hello world. So we're going to find that one, and we're going to do each one of those for I in L, and hopefully we're going to be able to join them up, and we should be able to get hello world back. So let's just try and do a decode. So print. In fact, what we might need to do, like just to test our encoding, we would E. We'll just do E is equal to, because that's going to be our encoded stuff. So I'm going to just X that out here and paste it in there, because we want to decode what we've just encoded. So we've got an E there, so that still works. We've just done an encode, and now we want to do a decode of the encode. So so we're going to do decode what we just encoded to check. Well, we won't even write to check, and that one hopefully should give us back what we expect. So we'll do a decode of E, just like that. And in fact, you know, what we can put is like a D is equal to decode of E, just so that we can explicitly sort of like see what we're doing there. D is a decode of E, and then we're going to return ourselves back D. Hopefully that will all work. And we get back decode what we just encoded, and it looks like it works. So we've now got an encoding and decoding. There's way more complicated and maybe better and sophisticated encodings and decodings, but I've kind of like done the live man-made hand-built version of a decode and an encode, and I've kind of like left it relatively complete. So we have our whole function, and I guess we could be more complicated with ciphers and things like that, or sort of like change the numberings, so like not have them as like contiguous integers, but do something more special with them. But that generally gets us to the encoding and decoding part, which helps us with the tokenizing of the input text. And this whole thing really is just called a tokenizer, so we can kind of like now move on to the next section, which I will create a new tab for over here, a new little block of code.